Welcome to the session on impact analysis setup. Here I am going to explain how to set up an impact case in Hypermesh using a RADIOSS user profile. To start with, I have taken simple example, that is an impactor hitting a roof. This impactor is traveling with an initial velocity of 34,000 mm per second in z-axis, and this roof is constrained in all degrees of freedom. That is, the master node of the roof is going to fix in all degrees of freedom, and I'm following this in a system that is mass in ton, time in second, length in mm, and force in newton. And these are the steps to be followed. Since I already have a mesh model, so I will just directly go to the step 3, that is create the property. To create the property, just right click, create property. I'm going to create a two property over here, one for impactor and one for roof. I'll start with the impactor. I'll select the formulation as I shell 24 and number of integration points are 5 and thickness is 1 mm. And similarly I'll create one more property for a roof. I'll just change the thickness to 5 mm. And next step is create the material. Similar to the property, I'll create a two material over here, one for impactor and one for roof. For impactor, I have taken a simple material, that is linear elastic material. To create a material, right click, create material, and start with an impactor, that is M1 material, that is M1 elast. I'll just define the row as 7.89 e raised to minus 9 and the angst modulus as 2.5, 2.1 e raised to 5 and mu as 0.3. One more material for roof, that is M36. I've chosen elastoplastic material for this. Define a roof, angst modulus, Poisson's ratio, and here I'm going to, for this material, I'm going to define a stress strain curve, that is using an n function. Since I have only one function, I'll say 1 and I'll select the curve. The curve which I'm going to select is already defined. As you can see this curve is already defined. You can also define the curve using xy plots curve edit, say new, and you can define, put the values for x and y, and the curve is going to define. And you can also review this curve, already defined one. The creation of material is over, and then we will go to the next step, that is assign the material the property. I'll start with the roof. We just assign the material and property to the roof component. Property as a roof, material as M36. For impactor, property as an impactor and material as a M1. The next step is create the boundary condition. And one more, I'll just add some mask to this impactor that you can do by card edit. Go select the element. I'll just select this rigid R body. I'll say edit. I'll go to mask row and I'll change this. And before creating the boundary condition, so as you can see this, I am going to define a boundary condition on the master node of a add body. So you have to keep a note of master IDs of these two card body that you can do by go to card edit element, select the R body, say edit, and see this node ID 2017244. Note of this ID. Similarly for the impactor, to create a boundary condition, you have to go to Utility Boundary Manager. First, I'm going to create a boundary condition on this impactor. So I'll say boundary condition. Change it to node. Select the node by ID. I'll constrain all degrees of freedom. I'll say create. And next, I'm going to apply initial velocity on this impactor. I'll change the type to initial velocity. And I'll select the node by ID. See this, one node is added. I'm going to apply initial velocity with respect to global axis. That is, you can also apply initial velocity in any oblique direction by defining the skew. Just say create it. And also I have to create a one more constraint on this impactor. I'll change the type to boundary condition and select the node by ID. So proceed, and I'll select all the degrees except the Z translation. Create. I'll go to model browser and I'll preview just now whatever I have created. The next step is create the contact. Here I am going to define a type 7 contact. To create a contact, you have to right click, create contact, give a name. I'll change the card image to type 7. I'm going to select the slave as a impactor since I have a fine mesh over on the impactor. I'll change this component. For master, I'm going to select the one which is in coarse mesh, that is the root. And these are the some recommended parameters for the type 7 contact, that is I state 4, I gap to 2, and F scale to 0.8, frequency is 0.1, inactus 6. This inactus basically helps in resolving the penetration issues, and I form to 2. You can also reveal this contact. And next is create the output blocks. Basically creating the output block will help in getting a required results for different entities. To create a output block, right click, create output block. Here I'm going to create 3 output blocks, one for the components, one for the rigid body, and one for the contact. First I'll start with the component. Select the number of variables 1 and I'll define default. Second one for rigid body. We'll change the entity to elements and element type to our body. Select the elements by collector. The last one for contact. I'll change the entity to group. Select the type server. Variable is 1. Default. The next step is check for the penetration and intersection. Go to tool. Select the penetration. Select all the components. Here I am checking with the help of thickness multiplier of 80%. Whenever you check this, your model should be free from intersection. If you have a penetration, is fine, but you can deal with penetration using inact parameter, that is all here in a contact type 7. And next is model checker. To go to tool, model checker, radius block, say run. Have to check for if you have any errors in your model. As you can see this, there are no errors. And you can also have a look on coordinates. These are the suggestions. If it is not mandatory, you can ignore them. And next step is create the engine file. To create the engine file, you have to on the solver browser. For that, you have to go to the solver browser, check this. It's already checked it. So I'll directly go to solver. For any impact case, the runtime followed is 0.12 second. And before creating a engine file, you have to decide on your runtime. Here I am using my runtime as 0.12 second. For that, you should define the card run. To do that, you have to go right click, create engine keyboard, run, define a time stop, 0.12 seconds, and I'm requesting my animation at frequencies at a particular frequency that you can do by right click, create engine keyword, animality. Have to define the frequency. I'm defining 5 raised to minus 3. At every 5 raised to minus 3, my animation files are written. And next I'm going to request for a result file to be written, that is at what time frequency or result should be written. That is done by using a T file. To create that, you have to right click, create engine keyword, T file, define the frequency here. I am defining it by erased minus 4, and you can also define the contour results that you can do by create engine keyword, anim element. I'll just checking for some basic output required. EPSP one message, hourglass. Now the model is ready to export. Just export the model, export solver deck, give them some name, and export. You can run this model using the radio solver manager. Select and say run. Already have my results are ready with me. I'll just show you how to show this animation. And also you can have a look on this curve. For any impact case, the curve should follow this pattern. By this I am concluding the session. Thank you.